Hello friends, today we shall discuss the regarding circumferential stress or hoop stress. So here we circumferential stress or hoop stress. Hoop stress. What is circumferential stress? Actually, if we consider a cylinder is like this. If it is contains some gas and the gas pressure is P, the pressure inside the gas uh, the cylinder will failure by tear off circumferentially and longitudinally. Circumferentially, it will uh, comes to the wall of this gas. If circumferentially like this, suppose this cylinder, this is cylinder, and if the length is L, and so the two lengths and thickness will be under consideration of this stress. So it will tear up uh, for the maximum internal pressure P. At that pressure, suppose we shall consider the pressure P is maximum when it will just tear off. Okay. So the gas pressure is unit area, it will so unit area it will exert it. So total force exerted by the gas inside the cylinder equal to pressure into diameter of the gas, that is we say it is big D, into L, that is length of the cylinder. Okay. Now cylinder can withstand force equal to Fc into area of the into L into T into 2. This force is withstand by cylinder wall. Therefore, Fc here is equal to stress, that is hoop stress set up in the material of the cylinder. Therefore, we can write Fc into L into T into 2 equal to P into T into L. L will out because it is two sides. Therefore, Fc equal to P into D by T, 2T, sorry, there is a 2. So, Fc equal to inside pressure, diameter of the cylinder, 2 into wall thickness of the cylinder. This is the hoop stress setup in the cylinder material, where P is the maximum pressure that can be withstood by the cylinder. Thank you today.